Hi all, welcome to our YouTube channel Math Universe with Dr. Naseer Ahmed. Today we are going to start with the chapter Application of Derivatives. And I'll mention the chapter name. Application of Derivatives. In short, I call as AOD. And we are dealing with PUC. And we are expecting 7+ marks from this chapter. Fine, nothing but only 8. Now, let us move on to concept. We have totally 3 exercises, and what I'll be doing is I'll take first exercise, that is weight measures, after discussing the concept, problems then and there from model paper. Similarly, the other 2 concepts. Okay. So at the end, I'm not going to solve all the problem. As and how complete the concept, then and there itself the problems. Recording, no? Oh yes. Now come to rate measures. Our first topic, rate measures. As the name suggests, we are here to talk about some changes with respect to the geometrical problem. So as in this topic, rate measures, all the problems are statement problems. Students actually find difficult to understand about a particular geometry. Are they talking about the volume or the length or the area? So first, this is the basic problem students face, which I have examined. Recording, no? Yeah. So to overcome this, I'll give you very easy logic. Listen carefully. See, if you have a length, what are the different units we can have for length? It can be centimeter, or it can be meter, or it can be kilometer. So whenever in the question, after a number, if they are mentioned centimeter or meter or kilometer, it's understood that they are talking about length. Similarly, area. What are the different units to measure area? It can be square centimeter, meter square, kilometer square is very rarely given, but let us have, no problem. Next, volume. What are the different units? Either cubic centimeter, square meter, and this is very rare anywhere. We can avoid this, okay? We can avoid this. Fine. Now, coming to our real world, which is the independent factor. See, coming to differentiation, we have got derivative of y with respect to x. What's happening here? Y is the dependent variable, x is the independent variable. So y is depending on independent variable x. So rate of change of y with respect to independent variable x. Correct now? So here, coming to our real world problems, who is the independent factor and which are the dependent factor? Think. In our real world problem, time is the independent factor. Whether we go in time or not to college, for example, let's suppose 8 a.m. clock will say 8 a.m. But whether we reach on time or not, we are lazy or we are getting absent, irrespective of that, clock will show 8 a.m. So time is not depending on us, we are depending on the time. So we all are depending on time. So with respect to real world, time is the independent factor. Due to which, when I want to have rate of change of length with respect to time, here I will give per second, again per second, again per second. So whenever you see the unit, centimeter per second, okay, length is changing with respect to time. Similarly, rate of change of area with respect to time. So per square centimeter per second, per square meter per second, and even for kilometer, but rarely we are nowhere using this, but let you have this. Okay. Then change of volume with respect to time. So again, cubic centimeter per second, cubic meter per second. So just by seeing the units, no, we can say whether we are talking about which particular, whether it is area, length or the volume. Now for example, if they have mentioned In the question, the statement is there, and they mentioned 8 cubic centimeter per second. Oh, cubic, nothing but volume, change of volume, and here per second. So with respect to time, over, job done. Let us suppose I got some decrement, and it is -7 square centimeter per second. So square centimeter, it is the area, and here per second, so time with respect to time. Like this we can always analyze. Okay, now moving on to one more part. See, whichever problem you are going to have, whenever there is an increase, as in how the time is passing, if the quantity is increasing, then for example, if y is, note number 1 here we can take, if y is increasing as x is increasing, then we'll say derivative of y with respect to x will be positive. Okay. Similarly, if y is decreasing as x is increasing, then derivative of y with respect to x will be negative. Okay, as y is increasing, as x is increasing, then derivative of y with respect to x will be positive. So this will be one important note for us while solving the problem. Kindly make a note. We'll start with the problems now. Okay. Dear students, having understood the concept on rate measures, let us move on to model question paper number 1, which is issued this academic year 2025-2026 from KSEAB. Let us proceed. A 1-marker question, question number 7 from model question paper number 1. Question says, let C be the circumference and A be the area of a circle. So geometry is circle. Okay. Statement 1. The rate of change of the area with respect to radius is equal to C. Statement number 2. The rate of change of area with respect to diameter is C by 2. Then option A, only statement 1 is true. Option B, only statement 2 is true. Option C, both statements are true. Option D, both statements are false. Now, let us examine statements one by one. In the question, they have talked about circumference of the circle and area of a circle. We know that circumference of the circle is 2 pi r. Okay, solution. And we also know area of the circle is pi r square. And the relationship between diameter and the radius. Don't forget, diameter is twice of the radius, or I can say radius is half of the diameter. Now, the statement number 1 is talking about rate of change of area with respect to radius. Rate of change of statement 1 is talking about rate of change of area with respect to its radius. Okay. So, formula to find area of a circle is pi r square. And since they are saying they want rate of change with respect to radius, r being the radius, we can differentiate this with respect to r. Here they are not said with respect to time. Per second word is not there. Very clearly they said with respect to radius. So I have to differentiate with respect to r, r being the radius. A is a variable, C is a variable, both are dependent variable, r is the independent variable. See, for different values of r, circumference will vary. For different values of r, area will vary. See this diagram? If this is the radius, again if the radius change, my circumference is changing for different radius, correct now? And even for different radius, area is changing. So r is the independent variable, the radius, and both area and circumference are dependent variable. So when I'm differentiating, derivative of a will be dA by dr. Derivative of a with respect to r, it won't be 0. It's same like the role of y in our y equal to f of x. No, y is dependent variable and x is independent variable. So y dependent variable is taken care by C and A. The role is taken care by C and A, and independent variable X role is taken care by R in this problem. So when I differentiate here, pi being a constant and R square being a variable, by using scalar rule, pi as it is, derivative of R square is 2R. Now, as per the question, I have to represent with respect to circumference. If you see here, what we have got here, 2 pi R. What is 2 pi R from equation number 1? It is the circumference. So, rate of change of area with respect to radius is circumference, and this statement is true. Statement 1 is true. Now let us move on to statement number 2. What statement number 2 is saying? The rate of change of area with respect to diameter is C by 2. Again, area we want. Okay, fine. But this time, see carefully, we want to analyze with respect to its diameter. To differentiate with respect to diameter, I should have my variable to be diameter there. So as you know that radius is half of the diameter, so we can just write A is equal to pi. What is R? Half of the diameter. And I give a square because square is there here. We are going to get A is equal to pi. Half square is 1 by 4 into d square. Or A is equal to pi into 1 by 4 will be pi by 4 d square. Now I want to differentiate this with respect to the diameter d. Why diameter d? They said the rate of change of area with respect to diameter. So we differentiate with respect to diameter d. So when I differentiate, derivative of a with respect to d will be this. Okay, don't get confusion. This is this symbol stands for derivative. Okay, and this is with respect to diameter d. If you want, we can change the symbol to some capital letter. But being an entrance student also, don't forget you should like CET also. I want you to get addicted to this type of things. Okay, or if you are not okay with this, I can change to capital D. Okay, but anyway, let's go with this. Derivative of d square with respect to d will be 2d. Now here, 2 ones are 2 twos are. What will you get? Half pi d. Now I want with respect to circumference. Coming to circumference again, what is d? 2 times of r. Let us substitute, because in circumference I have got radius. So pi, what is diameter? 2 times of radius. Now see carefully. What is this? 2 pi r. 2 pi r from equation number 1 will be c. So half as it is into c, or c into 1 is c. So I will get c by 2 derivative of the area with respect to diameter is half of the circumference. That's what they have said. So even this statement number 2 is also what? True. So let us come to the option. Both the statements are true. Option C is correct. Okay, I hope the things are clear. Kindly make a note. Dear students, let us move on to the next question from model question paper number 3. Then we'll go to model question paper number 2. It says the rate of change of area of a circle with respect to its radius r when r is 4 centimeter is a 1 marker question. It's a very direct problem. Question is on area of a circle, and I want with respect to its radius, and radius is given as 4 centimeter. So we know that solution, area of the circle is pi r square, where r is the radius, a is the area of the circle. Now since we want with respect to its radius the change in area, so we can differentiate this with respect to the radius r. So derivative of a with respect to r we are going to have, where a is the dependent variable and r is the independent variable. So pi as it is scalar rule we are going to apply because pi is a constant. Derivative of r square will be 2r. Now 2 into pi will be 2 pi. What is the radius? 4. So 4 2s are 8 pi. And here it is rate of change of area with respect to radius. Now since the length is in terms of centimeter, we are going to have square centimeter, because for area square units and the unit is centimeter per it is changing with respect to radius, so per centimeter. So for each centimeter, area is changing by 8 pi. So it also means that if I say for 2 centimeter, what's the change in the area? Multiply by 2, 2 8s are 16 pi. Okay, so the answer will be, okay, pi, it just I have to go for like, it's MCQ, but here I have to fill both the value, pi and pi is balancing, so 8, only 8 is the answer. Be careful, let us suppose we had 8 pi in the option, 8 pi is not the answer, only 8 because pi is already given in the question. Okay, now the same that question asked for 2 marker from model question paper number 2. The question says find the rate of change of the circle with respect to its radius r at r is equal to 6 centimeter. No change, direct same problem, only in place of 4 now they are given 6 centimeter. So area of the circle is A is equal to pi r square. Now let us write r properly, and now we are going to now we are going to differentiate this with respect to r. So derivative of A with respect to r will be dA by dr is equal to pi. Derivative of r square will be 2r. But what is the value of r here? 2 pi as it is. What is the value of r? 6 centimeter. So 6 into 2 will be 12 pi, and again since the unit is centimeter and for area it is square centimeter per centimeter, so 12 pi square centimeter per centimeter, nothing but for each centimeter area is changing by 12 pi. So if I say for 5 centimeter, the area will be changing by 5 times of this, nothing but 5 into 2 will be 60 pi. Okay, at that range it will change. First make a note of this. Okay, dear students, we are having one more question from the same model question paper number 2, and it's a 1 marker question. Question says the total revenue in rupees received from the sale of X units of a product is given by this. Then the marginal revenue when X is equal to 15 is rupees. We have to find what is the value. See, it's a straightforward 2 definition. We have total revenue and here marginal revenue. Okay, now what is marginal revenue? Marginal revenue is derivative of total revenue. Okay, simple as that. Just write properly. Right here, no space there. So total revenue. Okay, with respect to the X. Similarly, we have one more. Here it is total revenue and marginal revenue. There is one more, marginal cost and total cost. So marginal cost will be rate of change of total cost. Okay, fine. So ultimately, you have to take derivative. Now, total revenue is given here. So let us substitute in place of total revenue this expression, and we have to just straightforward differentiate. Having continuity and differentiability completed, there should not be any trouble. Here we have to apply sum rule, and for each of the term scalar rule. So 3 is a constant out. Derivative of x square will be 2x plus 36 out. X derivative with respect to x will be 1. 5 is a constant, so 0. So here we are going to have 3 into 2 will be 6. X plus 36 into 1 will be 36. We want the value at x is equal to 15. So at x is equal to 15, we are going to have 6 into 15 plus 36. 6 5s are 30. Borrow 3 here. 6 1 6 7 8 9 plus 36. It will be 126. 126. Option D is correct. Okay. Kindly make a note of this. Dear students, from exercise 6.1, I have given assignment. Here it is for total revenue problem and here it is total cost. As I said, marginal cost is rate of change of total revenue. I mean to say total cost. So again I repeat, marginal cost is rate of change of total cost. So expression given, just we should differentiate and put x value is equal to 17 and get the answer. Kindly make a note. Fine. Dear students, having understood rate measures and solving all the problem from rate measures, now it's time for increasing and decreasing function. Let us try to understand the concept of increasing and decreasing function. When do you say a function is increasing? Just see carefully. Always the graph will be the one which is going to help us understand better. So see this curve. As and how x is increasing, y is also increasing. This curve will take as y equal to f of x. Now before I go ahead for this, just see, go to very elementary level. If I have got any point p of x comma y, and if I talk about the point, see this from the origin, this value is x and this value is y. We prefer mod because the point can be in any of the four quadrants, but length cannot be negative. But when we take in first quadrant, we are not going to write mod for x and y because in first quadrant both x and y are positive. Now see here, if I talk about any point here, that is x1, and one more if I take any point here, x2. Yeah, is it looking perpendicular? Yes. See, when I put x is equal to x1, I get the corresponding y value, that is f of x1. That f of x1 is this. F of x1 is here. Similarly, when I put x is equal to x2 here, my corresponding f of x2 is this. And if I talk about the point here, see carefully, when I talk about point, my x coordinate will come from x-axis, my y coordinate will come from the line which is parallel to y-axis. So here x1 and f of x1 will be the coordinate here. So x1 comma f of x1, and similarly here x2 is here, so x2 comma f of x2. Okay, is that fine? Now from the diagram it's very clear that x1, this is for increasing function. See this, x1 is less than x2. Correct? Now, as now you go to the right of x, the value will be always increasing. Even though I have taken the alphabet, they have not taken a number, but since x1 is before x2, and as and how we just move on. For example, if I talk about here only, if I talk about here, 5 is the number here. Next number, what is the next number? Don't say 6. Many will only focus on integer. No, the next number is more than 5. Not even 5.1, more than 5, because between 5 and 5.1 there are many numbers. 5.01. Again, between 5 and 5.01, these many numbers, infinite many numbers. Okay, more than 5. So always write to the x-axis, the values of x is increasing. So x1 is less than x2, and f of x1 is this, f of x2. If you just go along y-axis also, if I have got here some number 3, the other number will be more than 3. So surely what I am saying is here we are going to have along y, as if I climb up, the value will be increasing only. So f of x1 is here, and f of x2 will be here. So f of x1 is lesser than f of x2. You can see the height also. So f of x1 is less than f of x2. This is strictly increasing. Strictly increasing. A function is said to be strictly increasing if it obeys this condition that if x1 is less than x2, this will imply that f of x1 is less than f of x2. This should happen for all the numbers belonging to the given interval. Okay, this is strictly increasing. Now if I talk about one more, see carefully, strictly decreasing. Strictly decreasing. See carefully, strictly decreasing function. The strictly increasing function. Now we are talking about strictly decreasing function. See carefully. See this, it just goes down. Now again, if I take 2 points on x-axis, this is x1 and this is x2, and this curve equation is y equal to f of x. At x is equal to x1 and I substitute here, we are going to have this corresponding y value. that is f of x1. And when I take x is equal to x2 and I substitute here, I'm going to get corresponding y value, which is nothing but this length. Okay, this is f. Now, very clear from the diagram, you can see that x1 is less than x2, but you can see f of x1 is larger than f of x2. This should happen for all the element in the given interval. This is actually strictly decreasing. Nothing but there is no chance of equality here. Similarly, you can see there is no chance of equality here. Now, let us take one more. This is first, second, see one more. We'll take it here only. On it. Now, having understood strictly increasing and strictly decreasing, let us try to understand what is increasing function, decreasing function. Okay, so let us take this as third point. I'm just talking about when do we say a function is increasing function. And again, graphical approach is the best approach to understand. See here. So as now see this. I'm just drawing one graph. See this carefully. This graph, which is y equal to f of x, right? You see, in this particular interval from here to here, the value is always same, correct? So now, if I take this point to be x1 on x-axis and this point to be what? x2, and if I put x is equal to x1 and x2 here, same with this, whatever the logic I said, this will be f of x1 and this will be f of x2, this entire length I mean to say. So in this particular case, they are equal. But here if I take, let us suppose x1 here, then f of x1 here, if I take here x1, then okay, some other point, let us suppose x0, then f of x0 will be less than f of x1 as well as f of x2. So coming to increasing function, x1 is again less than x2, there is no doubt about it. But what will happen here is f of x1 can be less than or equal to f of x2. So you can see here we had strictly less than, but here we have less than or equal to also. But there's a chance that for some value it can be equal also. When only then we say it is what? Increasing function. And again it should happen for all, okay. This is always true for any point. When I'm writing this, I mean to say that it should not happen, no, that for some other value it is decreasing. When this one x1 is there, it has obtained one value, f of x1. The value of f of x1 should be always lesser than other set of values after x1. Nothing but f of x2, f of x3, f of x4, whatever I get. For that, either f of x1 should be equal to that, like this, or it should be less than. Okay. And undoubtedly, in all our cases, x1 and x2 are what? Different. They are distinct. Okay. Obviously, if they are same, there is nothing to talk about because same is what? Both are the same. X1 and x2 are same. So at the same point, we'll have same function value also. Correct? Now, what about decreasing function? When do we say a function is decreasing function? A function is said to be decreasing function. Again, same. There should be some a small interval, as you can see, x1 to x2. All the values are same here. Similarly, here as well. See this carefully. Now you see this carefully, decreasing function. And again, at this point, x1 to let's say x2. Can you see here? It's almost what? Equal values. And I think x1 still more. That I see from the view of camera, yeah, it is looking better. Actually, no, your view and my view are a bit slightly different. Doesn't know many times. Okay, anyway, that's the reason I just went to the camera view. Is it looking what I want you to understand? Okay. So y is equal to f of x. Now again, if I say this height and again this height, both are same. And this will be our f of x1 and this will be our f of x2, as it was here in this case. This was f of x2 and this length was f of x1. So again you can see that x1 is less than x2, but f of x1, f of x2 can be equal, but if I take somewhere point here, let us say x0, this will be larger than f of x1. So in short, what I'm saying is, trying to comment here is, I can have a point where I can have equality also. And be careful, purposely I have taken a graph to make you understand. So there should not be a confusion, sir. They should be equal. No, why there is equality sign not means along with equality, why less than sign is there. I am talking about all the points. Need not be only these 2 points. It can be anywhere. Okay, similarly it can be anywhere. Okay, on x-axis. When I say anywhere at this particular region, you can see it will be inequality coming into picture. Nothing but f of x1 will be less than f of x2. Okay, and again this is happening for all x1 comma x2 belong to I, and it can have a small interval for which it can be equal also. That's the essence of this, whatever I'm trying to convey a message for you. Now is the question. Now the question is it every function is always increasing, decreasing? And this we call monotonic function. Let us have this here. Monotonic function. What is monotonic function? A function which is either increasing or decreasing. This we call as monotonic function. So as soon as we say monotonic function, all these 4 cases come into consideration. Now next, is it something like always a function is always what? Increasing, or always decreasing, only strictly increasing, only strictly decreasing? No, need not be. See, one graph I will take here. It need not be always increasing, decreasing. See this, just one graph I am taking here. Now see carefully here. Here it is increasing, but after this point till here it is decreasing, and again it is increasing. This is an example from the graph. You can see neither increasing nor decreasing. Okay, this is an example for neither increasing nor decreasing, a general graph I have taken. And one question might come, sir, do we have any example? Yes, we have. For example, sine function, the best example. In discuss, I will be in the detail I will be discussing a bit later, but in this section only. But you can just see here itself, no? See this? It is increasing and then decreasing, okay? But in detail we'll discuss later. Now, see next one. One more example can be a constant function. Example for this, okay? Constant function. See, constant function. This is also an example for neither increasing nor decreasing. We know constant function is y is equal to f of x is equal to c, where c is any real number, correct? No? So if we recall the graph of this, the graph is a line parallel to x-axis. This is y equal to c. It will never change the value. Now this is neither increasing nor decreasing. This is also an example for neither increasing nor decreasing. So I have given 2 examples here. Let us say A example and example number B. This both comes under neither increasing nor decreasing. So having understood this, let us move on to a theorem. Okay, kindly make a note. Okay, dear students, having understood the concept, let us try to take one theorem without any proof, which we are going to use to solve all our problems. Recording, no? Yeah. So see carefully. What the theorem? In the NCERT, the theorem is stated as theorem number 1. So let us go with the same number. So we have some assumption here that let f y equal to f of x be continuous. First, it should be a continuous function in the closed interval a comma b and differentiable. Nothing but I should be able to differentiate on the open interval a comma b. End points need not be differentiable. Okay. Then we have some points. F of x is increasing function if f dash of x is greater than or equal to 0. and this should happen for all the x belonging to the open interval. Derivative we want only in open interval. Second point, f of x is decreasing function if derivative of f is less or equal to 0 for all x belonging to a comma b. One more point, see carefully, constant function. See the graph of constant function once. First PUC you had as a 5-marker question. Constant function, nothing but function whose graph will never change for irrespective of whatever value we take for x. Y is equal to f of x is equal to c. How the graph looks like? This is x-axis, this is y-axis, and you see this is the constant function. Here, always for irrespective of whatever value of x. So for all x1 comma x2 belong to the interval I, f of x is always what? C. C can be any real number. It can be positive. If it is positive, it will lie above x-axis, the graph. If it is negative, C is negative, the graph will be below x-axis. If it is 0, it will be x-axis itself. It will be x-axis itself because equation of x-axis is what? Y equal to 0. Okay. So here, this constant function is neither increasing nor decreasing. So, wait. There's also some more function like this. Sin x. This is also neither increasing nor decreasing, but there's a difference. What? It is changing the behavior. See carefully. See carefully. From 0 to pi by 2, it is increasing. Pi by 2 to pi, the graph is decreasing. Correct? No, that case is not there here. So it is always constant. So this is one function which is neither increasing nor decreasing. So always a constant. This also we call as neither increasing nor decreasing function. But don't categorize this under this. Okay. This is always changing with respect to x. This is never changing. So if it is a constant function, it will be what? What will be the derivative? If f of x is f of x is constant function. If f dash of x will be 0, this should happen for all x in the open interval. Yes. What is the derivative of a constant? 0 only, no? Okay. So I hope this point is clear. I just want this regarding this to be discussed, that neither increasing nor decreasing. Yeah, better take it here. See carefully what I'm trying to say. I think the graph is too small. Let us take it here. See carefully the best graph now, y equal to sin x. Almost everyone are familiar to draw. So if I take y is equal to sin x, if you see this graph, it just goes up, then come down, and then goes up. See carefully. 0 to pi by 2, if you analyze, as and how I am going towards the right of x-axis, nothing but the values are increasing. Even my graph is also increasing. So before reaching pi by 2, all I can say, in the interval 0 to pi by 2, first point, when x is belonging to open interval 0 to pi by 2, what's happening? Y equal to sin x is increasing. Correct now? It is increasing. You can see. But from pi by 2 to pi, if you see, again the values of x is increasing, because how can I say? As and now you go right to x axis, surely the values are what? Increasing only. The values are larger only. You can see here the graph is dipping down. Nothing but is what? Decreasing. So here in the interval, what? Pi by 2 to pi, y equal to sin x is decreasing. Now a function having both the nature is known as neither increasing nor decreasing. What I mean to say, I should be able to predict either it is just increasing or decreasing. It can't have two behaviors. So this in the interval 0 to pi by 2 increasing, pi by 2 to pi decreasing. That was strictly okay. But third point, if I say in the interval when x's belong to 0 to pi, 0 to pi, y equal to sin x is neither increasing nor decreasing. Okay, fine. I hope this point is clear. So we have got an example where the function can be increasing, it can be decreasing, it can be constant, and it can be a function which is neither increasing nor decreasing. But in a sub-interval, it is either only increasing or only decreasing. But on overall, it is neither increasing nor decreasing. Understand this well, because after I complete the problem on this, we are going to have what? Maxima, minima. Okay. For that, this concept will be very useful. Kindly make a note. So, dear students, continuing with increasing, decreasing, continuing with increasing, decreasing, let's take some examples, some more examples. Coming to increasing function, and one more thing, any function which is either increasing or decreasing is known as monotonic function. What is monotonic? Monotonic function. It is defined as any function which is either increasing or decreasing. Okay. Now, let us try to have some more example. We have talked about trigonometric function, algebraic expression, about polynomials. If I talk about exponential function, what can we say about exponential function? See, the expression for exponential function y is equal to a power x, where x is any real number and the base a is always positive and a is not equal to 1. So why base is not equal to 1? If I take base to be 1, 1 power any number is what? 1. I'll get y is equal to 1, a constant function. At x is equal to 1, sorry, at y equal to 1, I'll have a line parallel to x-axis. And constant function is neither increasing nor decreasing. Okay, but anyway, coming to exponential function, it's always the base is not equal to 1. But a can be positive. But here we have got two cases. What? The base can be more than 1 and the base can be between 0 to 1. Now, when the base is more than 1, then the graph will be this. You can say it's strictly increasing. What it is? Strictly increasing. Function. Okay. Whereas if the base is between 0 to 1, the graph of this will be okay, and it is strictly decreasing. Strictly decreasing function. Now, having this, let us also go for, I think that I erase this heading increasing, decreasing. You may think I am classifying here, means at a time adding both increasing, decreasing. Okay, fine. Concept name I have written as it is. Okay, written as it is. Now, coming to logarithmic function also, don't forget both log and exponential function are invertible functions. They are inverse of each other. So, coming to logarithmic function. Logarithmic function. That is y is equal to f of x is equal to log x to the base a, where x is positive real number. A is also the base a is also positive, and a should not be equal to 1. Okay. Here also same thing. Y is equal to, I can always write y is equal to f of x is equal to a power x. What's the meaning of this? I'm writing y in terms of x alone or a constant explicit function. Okay. Now here again we have got base. The base can be more than 1 or the base can be between 0 to 1. Now when base is more than 1, then the graph will be like this. Nothing but it is strictly increasing. Henceforth, no, in place of writing strictly increasing function, I use S with an arrow mark upward. It's not a standard notation. You should write full spelling in examination. And for this, I will just use this S then with an arrow mark below. Nothing but strictly decreasing function. Now, coming to this, the graph of this will be this one. Okay. So again, this is strictly decreasing function. So with this, we are ready for the problems now. Kindly make a note. Okay. Oh, mic. Okay, dear students, let us move on to the problems now. Model question paper number 1, as you are aware, it is from the academic year 2025 to 2026, issued by KSEAB. Okay, so let us move on. Question says function f of x equal to a power x, which is an exponential function, is increasing on R if. So I just now discussed about exponential function, and then we analyzed that if at all it should be an increasing function. This is the graph or a graph of any exponential function whenever the base a is more than 1 and x is any real number. So base should be more than 1, only that it is increasing function, which is in option D. Okay, I hope these things are clear. Let us move on to next question. So it also means that for option C, no, it will be decreasing function, and this only if they give this one, it will be under two categories, two intervals between 0 to 1 and 1 to infinity for decreasing and increasing respectively, and for this function is not defined itself. Question number, this is one marker. Now moving on to question number 24, a 2 marker question. Find the interval in which the function f given by this is strictly increasing. For any function to be strictly increasing, f dash of x should be strictly greater than 0. Now first find the derivative of this solution. F of x is equal to x square plus 2x minus 5. From here I want derivative of f with respect to x. Derivative of x square will be 2x plus, here 2 into x, 2 is a constant, as keep as it is, we are applying scalar rule. Derivative of x will be 1 minus derivative of 5 is 0 because it's a constant. Therefore f dash of x will be 2x plus 2. Let us substitute here 2x plus 2 greater than 0. Solve for x. So sum of two term I can transpose. So 2x is more than minus 2. I can divide by 2 because I want only x. 2 being positive, inequality will not change. Inequality will only change if you divide or multiply by a negative number. So I'll get 2x by 2 greater than minus 2 by 2. 2 and half will get cancelled. So I'll get x is more than minus 1. So to be very clear, and here they are only strictly increasing. So just see here, minus 1, and I want all the numbers. See, the function is strictly increasing whenever x is more than minus 1, more than minus 1. Nothing but all the number larger than minus 1 will be right of minus 1. And since I have got strictly greater than, and we have an open ball here. So all the numbers here up to minus 1 to infinity will be that interval in which the function is what? Strictly increasing. Therefore, f of x is equal to this function x square plus 2x minus 5 is strictly increasing for all x belong to open interval -1 comma infinity. Okay, as a note, the problem is completed. As a note, you can just have what for which x the function will be strictly decreasing. So for strictly decreasing, f dash of x should be less than 0. Since this f dash part is same, see, only in place of greater than, here we have less than. So here also in place of greater than it should be less than -1. If you plot the number line -1, I want all those numbers which is less than -1, nothing but this side. So x will belong to open interval -infinity to -1. Okay, for this interval it will be strictly decreasing. This they have not asked. This is just additional information from my end to you. Kindly make a note. Dear students, kindly make a note of this 2 assignment. Okay, from exercise 6.2 on the same concept. Be careful. Here you have got negative for degree 2. Okay, and here surely when you are going to differentiate, you will have a -4 here and -2 here. And when you are going to divide by -4, the way we have divided here, since it's positive, inequality will remain same. But if I had -2 here, so I have to divide by -2 to get x. Then if I'm dividing by negative number, inequality will reverse. Greater will change to less and less will change to greater than. Okay, kindly make a note of the assignment. Okay, dear students, let's move on to model question paper number 2. A 3-marker question. Question says, find the interval in which the function given by this is strictly decreasing. Fine. Let's take the question. This time it's cubic, last time it was quadratic. So f of x is equal to 2x cube minus 3x square minus 36x plus 7. Now if I differentiate this, so 2 as it is scalar rule, derivative of x cube will be 3x square. Don't forget, we are using the formula derivative of x power n with respect to x is n into x power n minus 1. In place of n we have 3. So 3 x power 3 minus 1 is what? 2 minus 3 again x square. In place of n we have 2. So put here 2 into x power 2 minus 1 is 1, then minus 36. Derivative of x with respect to x is 1. Derivative of 7 being a constant, it will be 0. So we have got f dash of x is equal to 2 3s are 6 x square. Then again 3 2s are 6 x minus 36. Now let us first find the roots of this. So I am going to equate the first derivative to 0. Okay, so we are going to have 6x square here, then minus 6x minus 36 I mean to say is equal to 0. All are divisible by 6, so I can divide by 6. Many will think of dividing here and they will write f dash is equal to what I am going to divide here. No, what will get here after dividing this expression, correct? So many will say divide here and let f dash is equal to this, which is wrong. If you are dividing, should be both the side and it will be 1 by 6 here. So that's the reason I have divided here. Here also the 0 by 6 is there, but 0 by 6 is what? 0. So don't divide here. Divide it here. Okay, because you are going to factor from here. Now 1 into 6 is 6. So 2 3s are 6. So I want factors. So since I have negative, 2 minus 3 will be negative. So I can write x square minus 3x plus 2x minus 6 is equal to 0. Now here common is x, so remaining will be x minus 3. Then here common is plus 2, so I'll get here x minus 3, correct now? Then here it is x minus 3 and the uncommon term x plus 2 is equal to 0. If we equate each factor to 0, we get x minus 3 is equal to 0 or x plus 2 is equal to 0. So from here either x is equal to 3 or x is equal to minus 2. Now we are going to take a table to talk about the behavior of f dash, the sign that will give the behavior. I repeat, we are going to talk about the sign of f dash that will give the behavior of the function f of s given here. Now for that, let us see the number line. If I plot the number line here, it's a will plot. See here 3 and minus 2, so first minus 2 should come, then 3. So I'll be having 3 intervals here, 1, minus infinity to minus 2, then minus 2 to 3, and lastly 3 to infinity. Let us take that one here. I think I will be needing some space. First, we make a note of this. I'm going to erase, make a note. Okay. Now, let us go ahead. We are going to have a table containing intervals, then f dash expression. What is the f dash expression here? It is this, but I can take 6 common here. Let us have a simplification. Yeah, see, if I take 6 common, then I'll get nothing but, see this, forever if I've taken 6 common here, 6 is here, everywhere 6 is. So I'll get 6 times of what? X minus 3 into x plus 2. This common sense logic I want you to understand. Then again factorizing. Since this one is taken here, I have divided by 6, nothing but I have taken 6 common out. And after factorization, I got this as the factor. So multiple of 6 should be following everywhere if I want to write for this the factors. So f dash is 6 times of x minus 3 times of x plus 2, and then I want to talk about behavior of f of x. Okay, now let us move on one by one. See carefully. First interval is minus infinity to minus 2. Now you can take any number from this interval and you can check the sign. Don't forget, as we discussed, if f dash is greater than 0, it is strictly increasing. If f dash is less than 0, I repeat, if f dash is strictly greater than 0, then f is increasing. If f dash is strictly less than 0, then f is decreasing. So the behavior of the function f of x completely depends on derivative sign. Okay. Now let's first set the intervals. Next interval is minus 2 to 3. And lastly, the last interval is 3 to infinity. Now, whatever number I take, for this now, I have to put each and every number which I take from here to these factors. But 6 is a positive number. So because of the 6 positive, I can write everywhere. Okay, I'll give a bracket. I have to multiply the sign. I have to multiply the sign. So take a number from this interval. Let's suppose minus 3. If I take minus 3, x is equal to minus 3. Put here minus 3, x is equal to minus 3. Sorry. So here minus 3 will be minus 6. Correct, no? You may think, sir, I have taken minus 3 because there is a minus. Okay, I'll do one thing. We can take whichever number you want, but in this interval. Let us suppose minus 10. Now put here. What will be x minus 3 value here? Minus 10 minus 3 will be minus 30, nothing but negative. We want only to know negative or positive. Similarly, this x plus 2. For x plus 2, again if I put x is equal to minus 10, minus 10 plus 2 will be minus 8, nothing but negative. So x minus 3 is negative, nothing but this is negative. And x plus 2 is also negative. So just see, plus into minus, minus, minus to minus, plus. Nothing but f dash is positive. If f dash is positive, the function is strictly increasing. That is the word for me. Strictly what? Increasing. Okay. Now, this computation need not to be shown, which is written here. So we can just do orally from here. Come on, take one interval. Take a number from this interval. Minus 2 to 3. Minus 2 to 3, some number 0. You can take whichever number you want. Okay. 0 is lying in this. 0 minus 3 will be negative 3. Nothing but it is a negative number. 0 plus 2 is plus 2. Nothing but is a positive number. I just want to know negative or positive. Plus into minus, minus, minus to plus is minus. So minus means negative and plus means positive. So this will be what? Strictly decreasing. Next, 3 to infinity. Take any number of your choice. Let us suppose 7. 7 minus 3, what? 4. 4 is positive. 7 plus 2, what? 7 plus 2 is 9. 9 is positive. Plus into plus, plus, plus into plus, plus. I hope you remember, no? School days. What is plus into plus? Plus. Minus into minus, plus. Minus into plus, minus. Plus into minus, minus. Okay. So here strictly what? Increasing. So what we can command? Therefore, f of x is equal to, what is the function? What is the function? This one, 2x cube minus 3x square minus 36x plus 7 is, they are only strictly decreasing, but they are what for both anyway. Is strictly decreasing, is strictly decreasing, strictly decreasing on this interval, and strictly increasing, strictly increasing. Where it is strictly increasing? See where is strictly increasing? Minus infinity, minus to union. Strictly increasing 3 to infinity. Okay. If they could have just asked decreasing, increasing, we could have taken close interval at the numbers, not at the minus infinity, not plus infinity. Don't forget, as a note, remember, both plus or minus infinity does not belong to R. In fact, R is open interval minus infinity to plus infinity. Okay, both are not real numbers. Minus infinity and plus infinity are not numbers. They are just a notation for a huge quantity, and this is for a least quantity. Kindly make a note. Yes, dear students, we are with the last question from this concept, from model question paper number 3. Prove that the function f given by f of x equal to x square into e power minus x is increasing in open interval 0, 2. So, let's first take the function. Now be careful, here we have to think of applying product rule because it's a product of two variable function. One is polynomial, other is exponential function. So if I differentiate this with respect to x, I have to apply product rule. Let's write that one also. Differentiate with respect to x. UV rule or product rule. So what it says, u into v, if I want to differentiate, keep v as, okay, I will differentiate u, then keep v as it is, then keep u as it is, then differentiate v. So as per the order, this is u and this is v. So now derivative of x square. What is derivative of x power n with respect to x? It is n into x power n minus 1. So in place of n we have 2. So substitute then 2 into x power 2 minus 1 will be 1 into v. V is e power minus x, keep as it is, plus u, nothing but keep x square as it is. Derivative of e power minus x will be e power minus x. Recall, what is derivative of e power x? It is e power x itself into derivative of power, that is 1. But now here be careful, since you had x, derivative of x with respect to x is what? 1. Here we have minus x. So derivative of minus x will be minus as it is, x is 1. Okay. Now let us simplify. What is common? First let us simplify. 2x e power minus x plus into minus minus x square e power minus x. Common here is x into e power minus x. Common, you can see x and here e power minus x. So remaining will be 2 minus x square here, 1x is out and e power minus x already taken. Now I have got f dash. Now I have to equate to find what? The roots. If I equate this one to 0, see carefully, x into e power minus x into 2 minus x should be equated to 0. But this is an exponential function. We know that exponential function is always going to be positive, nothing but open interval 0 to infinity. So this cannot be equated to 0. Only have to equate 0 is these two polynomial factors, x is equal to 0 and or 2 minus x should be equal to 0, any one. So from here if I transpose this, I'll get x is equal to 2. So I've got two rules, x is equal to 2 and x is equal to 0. So now let us plot on the number line. If I plot on the number line, that is 0 and 2, here plus infinity, here minus infinity. So we have three intervals. Okay, and you should see that the way I'm marking on number line, 0 and 2, I'm not marking plus infinity nor minus infinity because both are not real numbers. Now, okay, let me create some space here. Let me erase this side. First, you copy this. I'm going to erase this all. Hope taken. Okay. See carefully. Now, intervals. And then f dash of x, which is equal to x into e power minus x. First I write e power minus x, then x, then 2 minus x, and then behavior of f of x. Now, listen carefully. I just wrote this one first, then there's no problem. A into b same as b into a. There's a reason also, you'll come to know shortly. Minus infinity, comma 0 is the first interval, then 0 to 2 is the second interval, and the lastly the interval is 2 to infinity. Actually speaking, they are only asking the interval 0 to 2, so let us not be bothered about this, but as a completion, let you also understand. But in exam, you can only talk about 0 to 2 interval. Okay, now you see, first I will talk only about 0 to 2 so that you understand that problem is completed as soon as you get this one. Okay, 0 to 2, take any number of your choice, and before you take, don't forget exponential function is always positive. So whatever number you take will be least bother. For this I can always write plus. That's why I wrote at the left. Okay, now take any number between 0 to 2. Let's say 1 x value here, so it's positive. Put here x value 1. 2 minus 1 is what? Plus 1, positive. Plus into plus is what? Plus, nothing but greater than 0. So what's the meaning? Therefore, it is f of x is strictly increasing. That's what they asked. And then the job done. Okay, conclusion. Therefore, f of x is equal to x squared e power minus x is strictly increasing. Strictly increasing on open interval 0, 2. Now let us also go for the other interval. See, as I said, for exponential function is always positive. So for this I can write always plus here also and here. Now take any number from minus infinity to 0. Let us suppose minus 1. X is minus 1, so negative. And here 2. Here x is negative. No, x is what? Minus 1 we have taken. Minus into minus will be plus. 2 plus 1 will be what? 3. So nothing but positive. So plus into minus, minus to plus is what? Minus, nothing but negative. Therefore, f of x is strictly decreasing. I hope this point is clear. Now 2 to infinity, take a number, let's say 3. X is 3, so positive. Next here, x is 3, no. 2 minus 3 will be minus 1, nothing but negative. Plus into plus into minus is minus, nothing but negative. Therefore, f of x is strictly negative. I mean to say f of x is strictly decreasing. So therefore, we can say that it is strictly increasing here and strictly decreasing. Strictly decreasing on. For decreasing, minus infinity to 0 union, again decreasing 2 to infinity. Okay, but surely when I take CET class, no, there I can discuss one method known as Viveka method, where you can omit this table, but for PUC it's required. Kindly make a note. Dear students, having completed the concept of increasing and decreasing function as well as the problems for model question paper, now the last concept we are going to go for is maxima and minima. Now listen carefully the concept first. There are some confusion for the student. What is this point of maxima, point of minima, then that no point of inflection, turning points, what are this? So I would like to address each one of this and then we'll take up the problems. Okay, now listen carefully. First, let us take one curve. Geometry will give you a very clear idea. Now let us suppose the curve is, here I have a curve, it's a function curve, but I extend the x-axis till, okay. So now this curve is also, okay. Fine. Let us have the curve till here only, okay. Now let us say that the curve is given by y equal to f of x, okay. Now see carefully, there are some points which I want to name, label it. So here at this point A, we have got a function value to be capital A. At the point B, I have got function value to be capital B. Function value means after I substitute x, in place of this x value to be B, after I evaluate, I get some value that we call function value, that I am denoting by B. Similarly, after evaluating x in place of x here, I will get some value for y, function value which we call is capital A. Okay. Then C, that is for capital C here. And then here we have small d, and then for the capital D, and here E, and the function value is also having at the same point. Okay, fine. Now having this, let us try to go one by one. Okay, now listen carefully. And I not okay, did I not, fine, it will be there, no problem. We'll just talk one by one. Now coming to this, you see carefully, and increasing decreasing concept is very important. I hope you have gone through that in the same video I have discussed. See carefully here, when you just see this graph, which is the largest of all, maxima, largest of all if I talk about, which is the largest of all, is it A, B, C, D or E? It is C. So this is largest of all, and the largest of all we call absolute or global maxima. Nothing but when I say global or absolute, throughout the graph, only C is the largest. Similarly, throughout the graph, if you see, D is the least value. So this will be absolute minima or global minima. Here also absolute minima means absolute maxima or global maxima. Absolute minima or global minima. I hope till here clear. Now, but if you see this capital A, in this neighborhood of small a, the corresponding values are here. So in this small neighborhood A, See here, compared to all the value present here, this particular point, nothing but this point A, this is maximum in this neighborhood. Okay, in this neighborhood. That's why we call this as local maxima. Locally it is maximum, not overall, but in its neighborhood. In its neighborhood. In this neighborhood, that's the maximum value. Similarly, CB, capital B. This is also in this neighborhood, it is having the least value. Okay, so this we call local minima. Again, in its neighborhood, it is least value. Now, what about the point which is giving the local minima, local maxima, or absolute maxima, absolute minima? There is name for them also. Now here, this point x is equal to C, all on x-axis. So the point x is equal to A is responsible for local maxima. So this A is known as point of local maxima. What's the meaning of this? It is a point which is responsible to give what? Local maximum value. That's a point of local maxima. Then what about this? This point B is responsible to give a local minima. So this we call point of local minima. Now you come to this. C is giving absolute maxima. So overall, the largest value is what? C. That is given by small c. So I can also say the point of absolute maxima. Okay, and this D is what? Point of absolute minima. Absolute. And here when we are talking, it can also be said point of absolute minima said, or point of global minima also can be said. Okay, I meant to quote about what is E. But before I go ahead, see carefully. Here we have something known as turning points. What's the meaning of it? See this. This graph y equal to f of x. Here no, as in how the x value. See, always you go towards the right of x axis. As in when you go to right of x axis, value moves on increasing. If I have got 10 here, next number is what? More than 10. Correct? No. If I have got 15, next number is what? More than 15. It's never less than 15. Always, and here also, if I have got minus 3, next number is what? More than minus 3. Okay? It's always increasing. So always x is going to increase. Now, as you know, x is moving. You can see the curve here. It is increasing. Yeah, increasing. Then suddenly after reaching here, it is decreasing. There is a turn. Can you see a turn here? It just went like this and then it gave a turn. It gave a turn. This turn again, okay, turning point. This we call turning point. This also we call what? Turning point. Which are the turning point? Let us try to understand. Turning points. So which are turning points here? Yeah. Again you see, like going down, and suddenly I'm taking a turn. So B is also a turning point. Then I again turning point. C is also a turning point. Then down and again I turn. So it's a turning point. But you see here, there's no turn here. It just moves. This is not called turning point. E is not a turning point. This small e is not a turning point. But coming to turning point, as you see here, it is increasing, then decreasing, again increasing, then decreasing, again increasing. Correct now? So this turning point, as soon we go for a turn, we from increasing to decreasing, we have got maximum value, local maximum value. As soon we are turning here from decreasing to increasing, we have got minimum value. So the turning point are actually point of maxima or point of minima. That's what you can see. So what are turning points? It is actually point of maxima or point of minima, which is responsible for local maximum value, local minimum value, or global maxima or global minimum value. So these are turning points. ABCD are points of, it can be maxima, or okay, maxima or minima. Okay, it's understood. No need to specify local maxima, local minima. It's understood. Okay, for this item also local, and it can also be global also. Okay, for both I have mentioned. Now, this all called. Now, one general name I want to give before I go ahead. See this E. Now, just observe E. It's increasing, 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 and it's cutting x-axis again, increasing, increasing, increasing. What is this called? This point E is called point of inflection. Point of inflection. What is this point of inflection? It is a point for which we are not having any point of maxima, not point of minima. It's not a turning point. It's not a turning point. And all this point together, that is turning point, point of maxima, point of minima, and point of inflection, is known as critical points. Now, what is this critical points? Listen carefully. Critical points was the definition. Let us suppose that y is equal to f of x is continuous. It is continuous on whatever the interval is been given. Okay, let us okay continuous. I'll just mention. Okay, let us not specify any interval, only continuous. Then critical points are either f dash at that particular point, f dash of x should be 0, or f dash of x does not exist. Either the derivative does not exist, or if it is exist, the value at which we are finding it should be what? 0. Now for example, see carefully here. Let us take some other color marker. It will be overlapping. Now see this carefully. If I try to draw a tangent, don't forget if y equal to f of x represents a curve, then the first derivative stands for slope of the tangent. First derivative stands for slope of the tangent. So, see carefully. Let us try to draw a tangent at this local maxima, local minima, local and global maxima, global minima. If I draw a tangent here, is it visible? Yeah, visible. This color is visible. Fine. And I again overwrite on this. This one, this tangent at A is parallel to x-axis. Whenever the line is parallel to x-axis, slope is what? 0. So this particular slope f dash at A is what? 0. Similarly, here if I draw a tangent again draw a tangent here. This tangent is parallel to x-axis at the point B. So this is f dash of B is equal to 0. Okay, 0. See, this is about point of local minima, point of local maxima. Again, you come here. When I draw a tangent parallel, means passing through this, and this tangent will be what? See, I am trying to just draw a tangent at this point, and that tangent at this maximum value, I am trying to draw a tangent, and this tangent is parallel to x-axis at the point C. So this is f dash of small c is equal to 0. I hope it is visible. Yes. Similarly, come here, draw a tangent at this, and I draw a tangent here also. See carefully what is happening. Here we have f dash of d is equal to what? 0. That's what I'm saying for critical point. Either f dash at that particular point should be 0. Okay. So at that particular point should be 0, or it should not be differentiable. Only those are what critical points. Now the critical points can be point of maxima, point of minima. It can also be point of inflection. So how, sir? Just see here. Now here also the way this curve is drawn. No, you can see at E for this y equal to f of x. It's a tangent only. It's a tangent only here. You may think, no, sir, tangent means it's just touching at a point, particular point. No, for example, circle. So this is a tangent. You should just touch at a point. That's what in you have understood from school days with respect to circle. What is the definition of tangent for circle in school days? What you have learned is it's a line which will touch the circle at a point. Correct? No? But actual definition is it is a limiting case of secant or chord. That I have very clearly explained in differentiability, continuity and differentiability chapter number 5, which is already uploaded. We can just go through geometrical meaning. I have explained very clearly. I have explained. So kindly go to that. Now here, this E, you can see the tangent. At this point, I have a tangent, and when I try to write the equation, means the slope of this, since this is the line on x-axis, slope of x-axis is also 0. So I'll get f dash of e also equal to what? 0. So whether it is point of maxima, local maxima, or point of absolute maxima, or point of local minima, or point of local means point of absolute maxima, for all this, if it is a continuous function, I draw, and if it's differentiable, if I draw a tangent parallel to x-axis, not only that, even for point of inflection it is 0. So critical points are those points if the function is differentiable, the derivative at that point will be giving you 0. If it is or it can't be differentiable. So whenever you get this criteria that a function on after differentiating, if I evaluate, either I'm getting the derivative to be 0 or I'm not able to differentiate. So not able to differentiate, how come? Yes, we have, for example, see this y equal to mod x graph, or I can go general only also, no problem. I can just draw one graph for you. Now see this. This is the graph. What's the least value here? The least value of this is, let me take the other color. At origin we have got 0, 0. So this is the least value, and point of minima also 0. This is point of minima. Point of minima. And what is this? This one. It is minimum value. And at x equal to 0 is not a differentiable function, as we have got a kink. As we have got kink. That's the reason I just said that critical points are those that if it is continuous, it is continuous again. Every modulus function is continuous. Either when I am going to differentiate, derivative of that will be always 0, or it will not be differentiable. So critical point is a broader sense. In critical point, if I am going to have turning points, that will be point of maxima, point of minima, point of local maxima, point of local minima. And we can also have point of inflection where the function is going to have derivative to be 0, but that will not give you point of maxima nor point of minima. Okay. So having understood this, let us move on to the one more concept. Let I erase this. If not, I think anyway you are going to have this one in your means it's recorded session. So I'll try to incorporate some concept of first derivative and second derivative. How are you going to talk about point of maxima, point of minima, how to identify, because always we are not able to draw the graph. Okay, see carefully. If you see this, now first I am discussing first derivative test. Let I erase this part. Let I discuss first derivative test. Now what is this first derivative test? So to find local maxima and local minima values. So what is our intention? We want to find local maxima, local minima, and in this we are going to go for first derivative test. First derivative test. Now what it says? Now comes increasing, decreasing. Recall. Just see the single. Come on, recall what I said there. As and how the curve is moving up, it's called increasing function. And as soon I come down, it's called a decreasing function. Again what? Increasing function. Again what? Decreasing function. Correct now? And if it is increasing function, first derivative should be positive. For decreasing function, first derivative should be negative. Correct? So having that logic, let us try to move on. How to know the given function will have local maxima, local minima. See carefully. Pay attention. Ready? Here, if you just see, this particular graph is increasing as how x is increasing. So if I try to draw a tangent here, so see this carefully. In the neighborhood of A, let us suppose the neighborhood now here and here. In this side I have got, let us use some other color. Kindly focus, pay attention. Here the neighborhood is, here I'll take a minus h, and here I'll take this point to be a plus h. Here h is positive, okay? Here h is positive. So since h is positive, a minus h will be left of a, because it is a minus h is less than a, and a plus h is more than a. So it is here because h is positive I have taken. Now see carefully. Now when it is here, now very clearly that just before a, the function is what, increasing. Therefore very clearly that f dash of a minus h will be positive. F dash of a minus h will be positive because it is increasing. As soon as cross a, you can see now it is decreasing. Now it is decreasing. Let us have this till here it is, okay. Let I just draw the graph as per what I have taken. Okay, so this carefully you see here now. Okay, I'll do one thing. I'll take it here only, and I will shift the point bit to left. Okay, so that the clarity is there, visibility is there. Okay, here we have the tangent. Now you see carefully a plus h, the corresponding point is somewhere here. So if I draw a tangent here, you can see that very clearly. Now since it is decreasing, f dash in the neighborhood of a plus, in the neighborhood of a, that is a plus h, it is what? Decreasing. So it is, derivative should be what? Negative, because f is decreasing, therefore derivative should be negative. So what we can understand from here, that at the beginning f dash is positive, then after taking some value, what, f dash of a is 0, then it is what? Decreasing. Then it is what? Decreasing. So whenever in the neighborhood of a, if the derivative sign is changing from positive to negative, then we are going to obtain local maxima, and the point at which the derivative is 0, that point is known as the point of local maxima. Okay, so we can first note that if the sign of f dash of a, okay, f dash of x better, f dash of x is changing from what? Positive to negative, in the neighborhood of x is equal to a, then f of a is local maxima, or and x equal to a is point of local maxima, This is that. So read once. If the sign of f dash of x is changing from positive to negative in the neighborhood of x equal to a, then f of x is local maxima, and x is equal to a is point of local maxima. Yes, correct. Now come to this point B. See, again for the point B, if I just see carefully, okay. Now at this particular point, so again I'll take this neighborhood, okay, a small neighborhood I'll take, and I suppose again h is positive, so here it will be b minus h, and here it will be b plus h. Now see what's happening. At this particular point, if I again draw a tangent, here, okay, tangent here for a while. Yes. Now this, since the decreasing function, as we know, for decreasing function, derivative should be what? Negative. So here very clearly, f dash of what? B minus h is negative. Whereas, as and how I'm going to the right, it is increasing. And here, I have taken the corresponding points. If I draw a tangent here, so at this, since tangent is drawn here, okay, then follow by. So if I just try to draw a small tangent here, okay, then what you can see here, then this the tangent, let's write it here only. this will be f dash of b plus h should be greater than 0. Since an increasing function, for increasing function, derivative of that particular region should be what? The positive. So here what you can see, if the sign of f derivative is changing from negative to positive, the point at which it is changing, that point will be point of local minima, and the corresponding value will be local minima. Let us quote that. If the sign of f dash of x changes from negative to positive, in the neighborhood of the point, let us say x is equal to b, then f of b is local minima. Is it local minima? Yes. And x equal to b is point of local minima. I hope this point is clear. Now we will give a concept for absolute maximum and absolute minimum also, but even for that also we can find like this. That's not a problem. Now come to point of inflection. You see point of inflection. See carefully. From first derivative, always you can comment whether the point is point of inflection or the point of maxima, point of minima. See carefully here. In the neighborhood of this, here also the function is increasing. Here also the function is increasing. So here, if I talk about point of inflection, small window will create here. Point of inflection. Point of inflection. If you see x is equal to e, small e, in the neighborhood of this, if I take some neighborhood here, no, for example, let's suppose that I take here it to be e minus h, and here I take as e plus h. Whether you draw a tangent here or you draw a tangent here, in both the cases, what this tangent, whichever is drawn, you see that f dash of e plus h is positive here. Here also f dash of e minus h is again what? Positive only. Correct now? So there is no change of sign from negative to positive or positive to negative. So in short, as soon we see that we have a derivative at e is 0, and if you see in the neighborhood, there is no change of sign from negative to positive or positive to negative the way it was here. It was changing the sign in the neighborhood of a from positive to negative, and here it was changing the sign from negative to positive. So that's the reason we got here the point of local maxima, and here we got point of local minima. That scenario is not there. So for point of inflection, there won't be any change of sign in the neighborhood of that point for which derivative is 0. I hope this point is clear. So at x equal to 0, there is no change. At x equal to e, there is no change. There is no change of sign in f dash of x. At x is equal to in the neighborhood of, that's better. In neighborhood. Let me write it properly again. In neighborhood of x equal to e, there is no change of sign in f dash of x. That's what the thing, what is known as point of inflection. Okay, I hope this is clear. So this is about first derivative. Now we'll erase the graph and then we'll talk about second derivative test also. Fine. Dear students, now let us move on to second derivative test. Now we are analyzing second derivative test. Means we are discussing second derivative test. Second derivative test for what? For finding local maxima and local minima. We want to know this. Fine. Let us move on. Listen carefully. Again, I will try to draw a graph. This will be our second last concept. See this. Okay. The curve can be either in above x-axis or below x-axis. I have taken this curve. See carefully. I have got this curve whose equation is y equal to f of x. And here, okay, and here, I am talking about point of maxima and point of minima. Okay, and the curve can go still more beyond, okay. So it went like this and then like this, okay. So I'm still focusing on point of maxima and point of minima. See carefully, coming to point of maxima and point of minima, how we are going to go about. Listen carefully. See, coming to second derivative test, before we go ahead, recall some of the concept of what? Increasing, decreasing. At this point A, near in the neighborhood, it is what? Increasing, increasing, increasing. And then it is decreasing, decreasing, decreasing. But here, at here, f dash of A is 0. Now here, if I draw any tangent here, as we know, when I draw a tangent here, in the neighborhood of this, nothing but f dash of A minus h is positive. That's what we discussed. And here, in the neighborhood of this, no, f dash of A plus h is negative because it's decreasing. Correct? Now listen. Coming to second derivative test, what this test says. See, if y equal to f of x is differentiable function, first it should be a differentiable function, nothing but it should be continuous also. Differentiable function. Now see carefully what is happening. If you see carefully that, okay, first we'll have the function, then we will differentiate, and that's like in the working way also simultaneously. And also, let us suppose after differentiating, you got some points, let's say A, B, C. Okay, I'm talking about A now. Now see what's happening at A. I have taken the function, then I have differentiated equal to 0, I got 3 points. The 3 points can be what? Point of inflection also, or local maxima, local minima points, nothing but turning points. So here, from here, just see carefully now. As in how we are moving here, it is increasing and then decreasing. Increasing then decreasing. So if I talk about sine of f dash of x, the sine of f dash of x is in the neighborhood of A. It is changing from positive to negative. Positive to negative. Positive to negative. Nothing but what? Nothing but what? F dash is, if I talk with respect to f dash is decreasing. F dash is decreasing. If f dash is decreasing, is it not the second derivative of f dash should be what? Negative. Recall. If it is an increasing function, if f of x is increasing, f dash should be positive. Same thing. Here, sine of f dash is changing from positive to negative. This implies what? F dash of x is, when it's changing from positive to negative, f dash of x is decreasing. F dash of x is decreasing. Since f dash of x is decreasing, its derivative should be negative. I hope the logic is clear. Again repeat. Since f of x is increasing, its derivative should be positive. Now, since f dash sign is changing from positive to negative in this neighborhood A, so it means what? F dash is decreasing because the sign is changing of f dash from positive to negative. Therefore, second derivative is what? Negative. That's what. So first point, if f double dash at this neighborhood A, at the point A is negative, this implies x is equal to A is point of local maxima and f of A is local maximum value or local maxima. Enough. This point is clear. Many students know as soon as we give second derivative test working rule for second derivative test, working rule for second derivative test. Many will have a problem. Sir, how come for maximum value we are getting second derivative to be what? Negative. Is it not? It should be positive. I hope the logic is clear. Okay. Regarding no? Yes. Similarly, see here at the point B here we have got minimum value, that is point B. The value B. And here see carefully, this point B we know it is local minima. Correct? No? Local minima. Point of local minima. I mean to say. Point of local minima. And what is this? Point of local maxima. Now again understand, clearly listen. Before I first let us write it here. Before I talk about again increasing, decreasing for this, just see here. Again in the neighborhood of here, correct? If I take h here, so here it is b minus h, and here we have got somewhere here b plus h. So see carefully. If I draw a tangent here for this. And again for this, if I draw a tangent here, so what is happening here? Since it's a decreasing function, is it not f dash of b minus h should be what? Negative. Similarly, since it's an increasing function, very clearly here that f dash of b plus h should be what? Positive. So very clearly the sign of f dash is changing from negative to positive in the neighborhood of B. Correct? Now again recall, for decreasing function, the function is decreasing. Let's have like this. The function is decreasing. If it is decreasing function, okay, here also let's have a proper diagram, just increasing, okay, just what? Increasing. For decreasing function, is it not, if it is decreasing, f dash should be what? Negative. So see carefully here, since it is what? Decreasing and then what? Increasing. So it is negative to positive. For negative to positive, correct? Negative to positive. So see carefully, for negative to positive, so here for decreasing, since f of x is decreasing, f dash of x is less than 0, and here you see, if I talk with the sign of f dash, it is changing the sign from negative to positive. Let's comment here. Since sign of f dash of x is changing from what to what? Changing from sign of f dash is changing from what? Negative to positive. Changing from negative to positive. This implies, so it is changing from negative to positive, so it is increasing. The f dash of x is increasing, derivative is increasing. Since it is increasing function, is it not f double dash of that should be what? Positive. Okay, so we can say that from here the second point in this is, if second derivative of the point B is positive, this implies x is equal to B is point of local minima and f of b is local minima. Don't forget what is here. This is our actually f of b, correct now? What is this? Local minima. And here if I say the point is capital A, which is actually what? F of A is what? Local maxima. I hope this point is clear. So in short, like this, you should have to go that if at all I got a function, if I'm going to differentiate, find the derivative and equal to 0, I'll get the point. After I get the point, find the second derivative and put that point whichever we have got. If the second derivative is getting negative, the point which is giving us negative, the second derivative, that point will be local maxima. And f of a, nothing but if I put this x is equal to a back in the function, then I'll get the local maxima value. Similarly, let us suppose one more point I have got after differentiating for the first time equating 0. Again, I'm going to find second derivative and I'm going to put the value x equal to b, and that if I have got second derivative to be positive, then x equal to b will be point of local minima. And then the corresponding, if I put x is equal to b and evaluate, then I'll get local minima value. Okay, fine. Local maxima, let us specify here value. Here also local minima value. Now, point C I have taken. See, I have taken, be careful. I have taken 3 points because I want to discuss 3 cases. We did not get 3 points always or 1 point. It depends. For example, a function which is always increasing, nothing but monotonic, we may not get f dash equal to 0. For example, exponential function a power x. If I take a to be more than 1, this is a graph of exponential function which is always increasing. For this, if I take derivative of this, what's the derivative of this? A power x, and it's never equal to 0. So there is no point of maximum, point of minimum for this because it's never going to what? Turn. There's no turning point. It's always increasing. Okay. Okay. Now, third point. It may also happen that I got the second derivative. When I evaluate that, I got 0. Then, if it gets 0, then test will fail. Test fails. As soon test fails, we have to go back to first derivative test, which I have just taught. Now, this is about second derivative test. First, make a note. And I've given you a valid reason how come we get this. Let us suppose, no, this is not the point with respect to the examination. Examination, this is the point for us. But we should know what is happening and why it is so that usually you think if maximum, we should have positive, minimum, negative. While in the derivative, we are not having so. And this is also a curvature. You can see, no? Curvature. Curvature. That's another. This curve is coming down. One more extra information I'm giving, that this is coming down. And it's going, this is also coming down. This is concave downwards and it's going up. This is called concave upwards. Okay, just an extra information. Now let's move on. Kindly make a note. Dear students, having understood marker. Okay. Fine. Dear students, having understood second derivative as well as first derivative test, and here whenever second derivative test fails, we are going to go back to first derivative test. Now, having understood this, no, we can think of 2 examples about this point of inflection may occur, may not occur, how it is so. Certainly that will be, no, the thought will be there. Do we have any example for that? Yeah, see, if I talk about y equal to x cube, and one more example is y equal to x power 2, the best example for you. See, y equal to x cube graph is this. And then we'll start with the problems. See carefully. This is the graph, correct now? Now it is increasing, 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 increasing. Now, see carefully. Can you see a change of bend here? This is concave downwards, which I discussed now. It's called seeing down. The curve is seeing down. That's called concave downwards. And this is what? Upwards. And you can see here at x equal to 0, y is also what? 0. Now if I find, I want to know, is there anyway f of x. If I differentiate this and equal to 0, I'll get 3x square is equal to 0, or x square is equal to 0, or x is equal to 0, 0. Now is 0 comma 0 point of maxima minima. If I want, for that what I have said in second derivative test, find the second derivative again. If I find the second derivative again, see carefully, derivative of x cube is 3x square. Again, if I differentiate this, then I write it again for you. F dash is 3x square. If I differentiate again, I'll get 6x. And if I put f dash double dash at x equal to 0, what we get? 6 into 0 is 0. That's what I'm saying. Test fails. And this is a point of inflection. Wait. As soon as I have got test fail doesn't mean that it's a point of inflection. That's what I want to make you understand. We shift back to what? First derivative test. Here, second derivative test failed. I went for second derivative test, and here, second derivative test failed. Now I will go to first derivative. Coming to first derivative test, what we are going to do? Find, till here same, no? We are going to equate to 0 and find the roots. Roots are even, number of times repeated, nothing but I'll put a number line 0. Now I'll apply Wavy-Curve method. What Wavy-Curve method says, after finding the root, equate to, means after finding the root, plot a number line. And since this is a present even number of time, we'll give a cross. Cross means the sign. See, usually after we give the sign, we have to, as soon as we jump the point, no, we have to change the sign. But whenever power is even, we are not going to change the sign, because even will not change the sign. Okay, it will remain the same. Now for that, see, which sign should we start? See, x square multiple positive, or you can see here also x square multiple is positive, so it should be positive. Then again when you jump, it should be again positive, because the roots are repeated even number of times, power is even, so sign will not change, it will remain same. Whatever sign is there, same sign should be written. If I got negative, it should be again negative here. Now what's happening, you see, this is the sign of what? F dash, so it's always increasing. That's what, no, always increasing. Therefore x equal to 0 is point of inflection. Okay, in place of going for x is equal to power, it means, I mean to say, in place of y equal to x squared, no, I'll take y equal to x power 4. Things will be still more clear. Recall what is the graph for y equal to x square? It's a parabola. The curve is this. Correct? No? Same thing. X power 2, x power 4, x power 6, all the graphs. This is the y-axis, no? This is y equal to, this is y equal to x square. Now again, x power 4, see, this is y equal to x square. See this hand, okay? X square. As soon as I say y equal to x power 4, no? See the hand. It will just come closer to, this is y-axis, come closer to y. Again, x power 6, if I say, again it will come closer. It become narrow. It will come still more closer. Again, x power 8, still more closer. X power 10, still more closer. Still more closer for all even higher powers. Similarly, y equal to x cube. It is like this, no? See? Again, what happened? X power 5, again the curve will be here. It will be very, very, still more closer to y-axis. So the curve like this it will be. This will be y equal to x power 5 for your clarity. Okay, and you let us not have it, because too many things on the graph, no, it will not be good for you. Let us understand one by one. Now see this. For x power 4, again the graph will be looking like that only, and it will be still more narrow. Yes. Now from the graph, it's very clear that x equal to 0. See, when x is equal to 0, you can see here, no, 0 comma 0. So x equal to this point of local minima, and this x equal to 0 is minimum value, local minimum value, local minimum, local minimum value. It's very clear from the graph. This is a simple one. We can draw the graph, and since I have said you the logic, then you understood, correct? No, but how about second derivative test? Let us try to understand why second derivative, as soon I get 0 at a point, why we said test fail in second derivative test. That is my intention for these two problems. Okay, here we understood In fail, we got point of inflection. But as soon fail, many will think that is it always as soon second derivative test fail, is that point of inflection always? This I want to answer. This I want to answer. Listen carefully. Ready? So, see, again for this, I will perform second derivative test. Let us perform second derivative test. For that, take the question. Find the derivative. 4x cube will be the derivative of x power 4. Then equal to 0. Then 4x cube is equal to 0 or x cube is equal to 0. X will have 3 roots because power is 3. Okay, for cube will be 3 roots. Now again find the derivative of this. 4 as it is, x cube will be 3x square. 4 3s are 12 x square. So f double dash of 0 will be 12 times of 0 square. 0 square is 0. 0 12 is what? 0. Second derivative, again we got 0. And this is what? This is saying what? Test fails. Test fails. Why we are using the word test fails? Why could have not just said as soon second derivative 0, that point is point of inflection? See the reason here. In this example number 1, second derivative is 0 and we analyzed and came to know that is a point of inflection. From the diagram it is very clear that this point is not minimum value because still for all these x value in the neighborhood, still we have lesser value. Correct? And we also came to the point of inflection. But here if you see from the diagram, compared to in this neighborhood, compared to all this value here, this is the least value, nothing but x equal to this value. When x is 0, point of local minima, x equal to 0 is local. I repeat, for x equal to 0, point of local minima, y equal to 0 will be local minimum value. And there is no other value greater, means to say there are no other value lesser than this. So it's very clear from the graph that this is our local minimum value. So as soon we get second derivative test to be 0, I can have both the chance, point of inflection or local minimum value. So again here, first derivative also can give the answer from here as soon the test fails. What the first derivative says, after finding the first derivative equating to 0, whatever the roots is there, plot here. Here number of roots are odd. For odd you are not going to give any cross because odd power will not convert negative to positive or positive to negative. Okay, now? And again you see x cube, the first derivative expression in that x cube multiple is positive. So sign with plus. As soon you jump, you should change the sign to negative. Is that clear? So see carefully now what's happening. This is the sign of what? F dash. So f dash sign is changing from negative to positive. Nothing but first it is decreasing and then it is what? Increasing. Since it's decreasing to increasing, therefore this is what? Minimum value, or x equal to 0 is point of minima. That's what you got, no? Point of minima, local minima. I hope this is clear. Always first derivative will have the answer for drawback or as soon we stuck in second derivative test. Okay, I hope this point is clear. Now with this we are ready for the problem. Kindly make a note. Okay, fine. Dear students, we have one last concept, that is absolute maxima, absolute minima. We addressed when I just took the concept of maxima, minima, but how are you going to find that? Okay, so let's have that. So now we are just interested on absolute maxima and absolute minima. Nothing but global maxima, global minima also we can say. Now see this graph. Again, graph is the one to make the things clear. See, I have got the graph. Purposefully, you see, I always try to draw the graph because things are very clear in this. And now I'm specifying an interval which was not given previously. So many times students have a confusion, no? How to know we have to go for maximum or only local maxima, minimum or only local minima. See, whenever I just say maximum, minimum, we mean to say absolute maxima, absolute minima. Now, how to know? Whenever intervals are specified. So, let us suppose that I have got a curve y equal to f of x in the closed interval a comma b, and I am taking this function to be continuous and differentiable presently. Now, see the graph. Can we see that? Let us try to again extend the graph also there. Okay, that's enough. So this is much sufficient. Now here, I've got one point where it is maximum, again here some minimum, and again here some maximum. For this graph, the absolute maxima is this point. So let's say this point, I will say this is C, this is D, and this is E. So this is capital C, this is capital D, and this is capital E. Okay. Now, in this largest of all is this, which is that E. This is your absolute maxima, and this will be absolute minima. So now what this concept says is, we are not going to go for what second derivative test now, first derivative test analyzing part. Just what we are going to do is working rule to find what absolute maxima and absolute minima. First, take the question. That's also I'm taking as a working rule. Okay, take the question. Then find the derivative of this. Then equate that derivative, and this function is given in the closed interval a comma b. That's very important. That interval is specified. Okay, that's how we come to know that it's absolute maxima minima question. Then as soon as I equate to 0, let us suppose that I got some roots, and these roots are C, D, E. By sir, from the graph if you see, if I just draw a tangent at this point, it's parallel to what? X-axis. Here also tangent is what? Parallel to x-axis. Here also what? Tangent will be parallel to x-axis. So this is at f dash, this entire line, not only at this point, this entire line. Okay, if I talk about slope at this C, f dash of C is equal to 0, and here what? F dash of small d is equal to 0. This is small c, mind it. This C, and here f dash of E is again what? 0. Okay, fine. Now let us proceed. So as soon we find the roots, let us suppose I got the roots, and roots are C, D, E. Now what we are going to do is just find the value of the function at A, C, D, E, and B. Find the function value at A, function value at B, function value at C, function value at D, and function value at E. Now, fifth point, commenting. Absolute maxima. What will be our absolute maxima? It will be maximum value, maximum of these values. Which values? This entire f of A, f of B, f of C, f of D, and f of E. Next, sixth one, absolute minima. That will be minimum of what? F of A, f of B, f of C, f of D, f of E. That's it. We always into the last point because it may happen. For example, I will take y equal to x square, and I'm talking about interval 0 to 2. The graph of this will start like this. Not x equal to 0 is a point of minima. So always we are going to take the endpoints. And this point which are taken CDE, it can also happen depending on the problem that CDE is one among this. And the most important, when you're evaluating this, you can see the diagram that CDE is in the interval of AB. That's very important. You should remember that this should belong to the closed interval A comma B. If I have got some point which is not in the interval, that point should not be considered while talking about absolute maxima minima, because we are confining to the interval. Previously, we are not confined to any interval. Okay, fine. So now we are ready for solving the problem. The new is x-axis and y-axis. Now we are ready for the problems. Kindly make a note of this. Okay. Students, let us move on to the problems from model question paper on maxima minima concept. Already increasing, decreasing, and rate measures we have completed. Now question number, okay, from model question paper number 1 of the academic year 2025-2026, issued by KSEAB board. What the question says. Question number 17 for 1 mark. The absolute maximum value of the function f given by f of x is equal to x square, where the interval is 0 to 2. Fine, is fill in the blanks question. Coming to the solution of this, f of x is equal to x square is given. Now recall the concept. We have to find the derivative and we should equate to 0. Derivative of x square will be 2x is equal to 0. Why? We are using the formula. What is derivative of x power n with respect to x? It is n into x power n minus 1. So in place of n 2, no? So here 2, then x power 2 minus 1. Okay, 2 minus what? 1 itself. Now 2, if I cross multiply, I'll get x is equal to 0 by 2. What is 0 by 2? 0. And 0 is there in the interval. That's what I said, no? That when you're finding the point after equating 0, that point can also be the endpoints also. Okay, so now I have to only find at x equal to 0 and 2, what is the function value? Equation number 1 is this. Find the function values. So what is f of at x equal to 0 in equation number 1? F of 0 is 0 square, nothing but 0. Then f at x is equal to 2, if I put in equation number 1, because 2 is the endpoint, so put here f of 2 is equal to 2 square, was the value 4. So we got at 0 the function value to be 0 and at 2 the function value is 2. So they ask maximum value, therefore maximum, absolute maximum value, absolute maxima or maximum value is what? 4. So fill in the blanks 4. But since this is, I just went for the usual way, but since this is a 1 marker question, we could have went for graphical approach also. Y equal to x, let's write it here only, graphical approach, the alternate way. What is y equal to x square? Graph looks like, actually the graph of this, okay, let's write it here. The graph of y equal to x square is this parabola, correct now? But in the question they started from 0 to 2. So what I should modify the graph? Since 0 to 2, 0 is here, correct? 2 will be somewhere here. So I have to only take this part of the graph, something but from here till here. This part of the graph should be rejected. And you can see yourself, it is going up, up, up. So this at this value. So put x equal to 2. 2 square is what? 4. So this will be 2 comma 4. So this will be your absolute maximum value, that is 4. Okay, anyway we can do it. But if it's a 2 marker question, you have to go in this manner only, otherwise graph. Okay, now let us move on to the next. Find the positive numbers whose sum is 15 and the sum of whose square is minimum. I have to find the positive numbers. Let those two positive numbers be, let the positive numbers be x and y. So very clearly I said x and y are what? Positive. Okay, let's write it here again. Dancing the statement repeatedly. They are saying sum is 15. Sum means addition. So x plus y is how much? 15. And the sum of whose square is minimum. Sum of whose square. So sum means addition. Whose square. So if I take the square is this, then I will take this as some a. If this is what? Minimum. If this is a minimum, then I have to find it. Okay, fine. Now let us proceed. Carefully listen. See, don't forget our syllabus. No, whatever we are having differentiation is of one variable, y equal to f of x. Whatever the concept we discuss is a one variable. I mean, say y equal to f of x. But here we have got two variables, x also, y also. That's the reason they will give you one condition like this. so that you can make our two variable to one variable. So this is my equation number 1. So what is y from here? Okay, I'll take this as y is equal to 15 minus x. This is our equation number 1. Okay, so we are going to have a is equal to x square plus, in place of y, what do we have? 15 minus x. Now from here we have only one variable, and a is taking care of both x and 15 minus x whole square there. So a is also a variable. A is in fact a dependent variable. Now I'm going to find the point of maxima, minima, nothing but second derivative test. And you can see in this question interval is not specified, so there is no absolute maxima, minima concept involved. So when I'm going to differentiate this with respect to x, derivative of a with respect to x is equal to 2x plus derivative of this is 2 times of 15 minus x. How? Composite rule. Recall what is derivative of x power n, n into x power n minus 1. First for this x square, in place of n 2, so 2, then x power 2 minus 1 is 1, and here again in place of x 15 minus x, so this is our n value, so n is 2, 15 minus x whole power 2 minus 1 is 1. Derivative of 15, recall we have to differentiate each and every term. After arrow done, now it is this term to be differentiate. Derivative of 15 is 0 minus derivative of x is 1. So now what is the answer? 2x. 0 minus 1 is minus 1, minus 2 plus is minus 2 times of 15 minus x. Simplify. 2x minus 2 into 15 is 30, minus minus plus, no? Minus minus plus 2x here. What is 2x plus 2x? 4x minus 30. So we have got the derivative, first derivative. Now equate to 0. If I equate the first derivative to 0, I get 4x minus 30 is equal to 0. Transpose 4x is equal to 30. Simplify now. If I cross multiply here, so okay, anyway, 2 2s are 2 1s are 2 5s are, okay, I'll get x is equal to 15 by 2. X is equal to 15 by 2. Now the question mark is whether this 15 by 2 is point of maximum or point of minima. For that, again I am going to differentiate this. So if I differentiate this with respect to x, we are going to have second order derivative with respect to x is equal to 4x will be 1 minus that is a constant. Derivative of constant is what? 0. 4 into 1 is 4. 4 minus 1, 4 minus 0 is 4. 4 I have got now at x is equal to 15 by 2. If I evaluate, what am I going to get? Second derivative. See carefully, in second derivative there is no x, it is only 4 which is positive. This implies x equal to 15 by 2 is a point of what? Point of local minima. Minima, not maxima, minima. If second derivative at a point is positive, it is point of local minima, and if it is negative, point of local maxima. That should be remembered. Property should be, that test should be remembered. Now I wanted those two numbers, so already got x value, y value I can put in equation number, means to get y value I can put in equation number 1. So put x is equal to 15 by 2 in equation number 1. This will imply y is equal to 15 minus 15 by 2. 2 is the LCM, so we will get 2 into 15 is 30 minus 15, so answer is 15 by 2. Therefore x is equal to y is equal to 15 by 2. Okay, we have got. Now let us suppose, no, they are only find the positive. Let us suppose they will ask you what is the minimum square number. Very simple. To find the minimum square number, put here both x and y value. That will give you what? Minimum number. Problem is completed. Problem is completed. Just I am going for an extra thing. Let us suppose that they are asking. I hope you have copied it. Oh, that's the cloth. Now let I erase this side so that I can complete that part also, which I have just said. Transferring orally, better to write. See carefully. Problem is completed. So let us suppose, no, extra. additional, I'm talking about some additional point here. Let us suppose that they're asking us to find what? That minimum value. Find say that is a find minimum value. We want that minimum value. Then that minimum value, how to find? Very simple. Come here, a value is equal to x square plus y square. What is x value and y value? Both are 15 by 2 and both are actually equal, no? So I can just put here 15 by 2 square plus 15 by 2 square. It is like a square plus a square. What is a square plus a square? 2a square. So 2 times of 15 by 2 square. So now it will be 2 times of 15 square is 225. 5 square is 4. 2 1s are 2 2s are. So value is 225 by 2. So simplify 2 1s are 2 1s are 2 2s are. Okay, 112.5 is the minimum value. Okay, is it clear? Kindly make a note of this. Dear students, let us move on to the next problem. From model question paper number 2, 25-26 academic year. Question says the absolute maxima value of the function f given by f of x equal to x cube, where x belongs to closed interval -2 comma +2. You will be wondering, sir, just now discussed y equal to x cube will not have point of maxima, point of minima. It is always increasing function. Yes, you are right. And we have got point of inflection only. Yes, but their interval was not specified. Here we have got interval, nothing but the figure is bounded. Bounded means it is lying between two numbers. Okay. For example, we know, for example, as soon as we are inside the room, we are bounded by floor and the roof, correct? No? Now, see carefully. I'll solve this in two methods. One, the usual method, other will be graphical method. Now, since I want absolute maxima, first I will take the question. Now we are going to differentiate this. Derivative of x cube is 3x square. Then if I equate to 0, we are going to have 3x square is equal to 0. This implies x square is equal to 0, or this implies x is equal to 0 comma 0. And this 0 comma 0 belongs to the interval, closed interval, -2 comma +2. Now, since we want absolute maxima, we have to check all the points. Now, don't check twice, okay? Only one sufficient here. So, now one by one, at this equation, we are going to substitute. At x equal to 0, in equation number 1, if I substitute, f of 0 is 0 cube. 0 cube is 0 itself. Next, x is equal to -2. When I put -2 in equation number 1, f of -2 will be -2 the whole cube. What is -2 whole cube? -8. Okay, fine. Then at x is equal to +2 in equation number 1, we are going to put here, I'll have f of 2 is equal to 2 cube. 2 cube is what? 8. Now, since we want absolute maximum value, the largest value. What's the largest value among 0, -8 and 0? It is 8. Therefore, absolute maxima value is +8. That is in option D. Now let I also comment about minimum. Come on, what will be absolute minimum value? Absolute minima value, even though they didn't tell, let us have it. 0 or -8. Many will say 0. No, -8. -8 is least of all the three. So it is -8. Okay. Now, sir, what the other approach you said? See, graphically alternate. But for this graph, knowledge should be there. What? Recall the graph of y equal to x cube. The graph is this. From the graph, it's very clear. The graph is always increasing function. Since I want maximum value and the interval is given -2 to 2, so if I put here, here is 2 and here should be -2, and here you can see 0, and you can again see the point of, okay, inflection there. Now see carefully. For this -2, for y equal to x cube, for this -2, if I put here, I'll get here what? And x is -2. -2 whole cube will be -8. And when x is equal to plus 2, for this plus 2, 2 cube will be plus 8. Okay, I came to know here absolute what? Write properly. Absolute maximum. And x equal to 2 is point of absolute maxima, and this is what? Absolute minima. That's what we can see very clearly from the graph, which we already got here also. But graphical approach will give fast. We can think of going with this approach. Anyway, it's a 1 marker question. No one is going to check the presentation. They just want the correct answer to be mentioned. And is what? 2 cube is 8. Absolute maximum value is 8. Now let us move on to this. When I discuss, I also talk about a function can be non-differentiable also for critical points. These are all critical points only. Yeah? Now see carefully. Mod function is not differentiable at the king point. I have discussed in differentiability. So how to get a king point? The term inside the mod equal to 0. I'll get x is equal to minus 2. Now, first, before going for graph, usual method I said, then I'll go for graph method. Both. Okay. Now here, usual way if I go, okay. Usual if I go, I want to find the range. Now how to find the range? What is the benefit of finding the range? Benefit of finding the range is what? That will give least value also, maximum value also. Correct? No? So mod of x plus 2. Mod of x plus 2 is always non-negative. It can be either 0 or it can be positive. When positive, anyway mod will give always positive. When I actually mean to say 0, very simple. Put this x is equal to minus 2 here. Minus 2 plus 2 will be 0. 0 mod is what? 0 only. Then we want minus 1. Add minus 1. When I add minus 1, okay, on both the sides, see carefully, mod of x plus 2 minus 1 get equal to 0 minus 1. Or I can say mod of x plus 2 minus 1 get equal to minus 1. I can also rewrite this one as minus 1 less or equal to mod of x plus 2 minus 1 less than infinity. Meaning to say that it is never going to have a largest value, it's just going to move up. How, sir? Let us try to draw the graph of that. It will be still more clear. To draw the graph only, I just found the king point. At x is equal to minus 2, I've got the graph. So first, the graph of x plus 2. See carefully. The graph of x plus 2 will be at x equal to minus 2, we have got king point. So this is my x-axis, y-axis, and this is minus 2. So the graph will be this. Okay. Whereas minus 1 is there, no? So minus 1. See, whatever the constant is there, no? The constant inside the mod will just shift the graph left and right. Where the constant is outside the mod, it will shift up and down because this is y value. Okay, now? So, see, y equal to, so the graph of mod of x plus 2 minus 1, how the graph will be. See easily. When x is equal to minus 2 here, minus 2 plus 2 is 0, 0 minus 1 is minus 1. Okay, the graph is starting at minus 1. So at the king point minus 2, the graph is going to go up. And okay, I just want to be sure when I'm drawing the graph, I want it to be perfect graph. I just want to be assured whether it's going to be right of the origin or left of the origin. For that, if I just equal to 0, I will get equal to 1. If I just solve plus or minus 1, 2 goes that side. Forever. I just want to see what I'm just trying to do is equal to 0 and get the x plus 2 is equal to plus or minus 1. So x plus 2 is equal to, if I just shift minus 2. 1 minus 2 is minus 1. Okay, the graph will be here. Okay, fine. I just wanted to be accurate. How to do this one is not required for you. Okay, how to know, etc. Now see, the graph just goes up. Again, here also the graph goes up, due to which it's not bounded. So minimum value, yes, is there at minus 1. That's what we also got here. Maximum value does not exist. So minimum value is minus 1. And if they ask maximum value, don't say infinity. Infinity and minus infinity both are not real number. Maximum value, extra point for you. Maximum, look at the extra point. Maximum value does not exist. Maximum value does not exist. Similarly, you see this graph. Question number, model question paper number 3. Question number 7, 1 marker question. The minimum value of this mod graph already we know, very simple. How to know the kink? The term inside the mod equal to 0. If I equate this one to 0, we are going to have x is equal to 0. So see carefully. Now you can see the least value is 0 here. Correct? The least value is 0. And what about the maximum value? Maximum value does not exist. Maximum value does not exist. And the minimum value is 0 at 0 only. Correct? Now minimum value is 0. So be careful. Here we have got 0 comma 0. So this 0 is point of minima and this value is minimum value. Okay. I just want to address one more point in this. This is a 1 marker question. This is also a 1 marker question. Before I just forget, one more point I want to highlight here. First make a note of this. See what I want to highlight. See carefully. This one confusion is there for the student. It's better to highlight here. Anyway, we are going for all the concepts. See, carefully listen. Let us suppose I have got a function y equal to f of x, and this is got bounded. Bounded nothing but it should be between two numbers. The way we are now, we are, for example, in this room. I am there. I am bounded between what? The floor and the roof. Okay. Now f of x is not equal to. Let us suppose it is between these two numbers. A and B I not use, capital letter I will use. Okay. You may think now always small letters are used for point of maximum, point of minima, critical points, and capital letters are used for the values obtained. So I will use this only. So first case is this. Second case is this. Third case is this. Fourth case is this. Now understand. Now as soon as f of x values are this, okay. Now here I am going to talk about what is the maximum value and minimum value. So here minimum value. When I say minimum value, absolute minimum value, okay. And here maximum value. Maximum and minimum value. Ready? See this carefully, analyze properly what I'm trying to make you understand, and listen carefully. See, we have been having this set of values. We have to comment whether it's maximum or minimum value for all this. What's the maximum minimum? First, when I'm saying I have got maximum minimum, we have seen very clearly from the graph, it was attaining that value. So here for this f of x is attaining both these value also, maximum value also. So minimum value is capital A, maximum value is B. Whereas in this second scenario, f of x is attaining the maximum value, that is B. Minimum value is not attaining. So some might say, if let us suppose that I have got a number 0 here and 1 here. Some will say, no, sir, okay, let us suppose I got some 3. Then some will say, sir, the minimum value is 1. No, it's not 1. Because between 0 to 1, there are many values here. Then there is 0.1 we can take. Again, between 0.1 and 0, there are many values. Whatever close you go, still there are many, but greater than 0 in this scenario. Therefore, here you cannot comment minimum value exists. You will say minimum value does not exist. Provided in this all case, I am assuming that f of x is increasing function. F of x is increasing function. And this scenario I'm talking about. Okay, if it is increasing, decreasing, means it is not the same case. And then in between I can have some intermediate values for which it can attain. I am talking about only increasing function. Okay, now here also f of x is attaining a value but not b value. So this is what minimum value is here. The maximum value does not exist. Does not exist. Even here also does not exist. Why? It's not attaining. It should attain. Does not exist. Does not exist. I hope this is very clear. And be careful, always A and B are real number only. When I say real number, I am writing here A and B. When I am writing real number is open interval minus into plus infinity. Both plus or minus infinity is not a real number. Not a real number. So there is no place for plus infinity, minus infinity. The way we have got here, problem we have commented does not exist. Okay, fine. Kindly make a note. Dear students, let us move on to the next problem from model question paper number 3. For 1 marker, question number 17. The number of points of local maxima and local minima of the function f given by. So we want number of what? Local maxima, local minima. Solution. See, as you know, I have to first find the derivative, and this will be 3x square by using the formula. What is derivative of x power n with respect to x? It is n into x power n minus 1. So then minus 3x will be again 1, and 3 is a constant 0. Correct? So 3 f dash of x is equal to 3x square minus 3. Now, if I equate the first derivative to 0, I'll also discuss the shortcut method also. I am doing this one so that in case the 2 marker question also how to do, it will be clear. So 3x square, f dash of x is here, I can substitute here. Then here common, okay, 3x square minus 3, okay. Common is 3, so I'll get x square minus 1 is equal to 0. I can factorize this, 1 is same as 1 square. So this 3 as it is, this is the form a square minus b square, so I'll get x plus 1 into x minus 1 is equal to 0, because we know a square minus b square is a plus b into a minus b. Now equate each factor to 0, I'll get x plus 1 is equal to 0. One more is x minus 1 is equal to 0. X is equal to minus 1, and here x is equal to plus 1. Now I should know whether this point is giving point of maxima or point of minima. For that, what we have to do is find the second derivative. Again, we find the second derivative of this 3 as it is, scalar rule, x square by using this formula. In place of n we have 2. We are going to have 2 into x power 2 minus 1, n minus 1, no. So 2 minus 1 will be 1. Okay, then minus, derivative of 3 is what? 0. So f double dash, I think was the second derivative, 3 2s are 6. Now here we are going to substitute the critical points. One by one we are going to know. So if I put f minus 1, okay, minus 1, okay, f second derivative at x is equal to minus 1, we'll have 6 into minus 1 will be minus 6. 6 into minus 1 will be minus 6, which is negative. So from here we can conclude this implies x is equal to minus 1 is point of local maxima. Why local maxima? As we discussed that whenever second derivative have got negative sign, it is a point of local maxima. Now similarly at x is equal to 1. So at x is equal to 1, if I substitute here, let's say this is equation number, okay, 1, no problem. In 1, this also I could have mentioned here that x equal to minus 1 in 1, okay, this is 1. So x is equal to 1 in 1, we are going to have second derivative at 1 is equal to 6 into 1 is equal to 6, which is positive. This implies x is equal to 1 is point of local minima. So totally we have got 2 points, okay, number of point if you talk about, we have one for point of maxima, other for point of minima, so 2. Other way, as soon we got this, we can avoid all this working. So the alternate. So dear students, now let us move to the alternate procedure. See, this alternate I am giving only because it is a 1 marker question, going to solve this much. After this we can avoid this working. Okay, but if it's a 2 marker, you are going to go ahead with the usual one what I have said. Now we are going to go for first derivative test. For that Vedic method we are going to use. So here minus 1 plus 1 is there, so that's a root, plot the root on the number line. And now you have to decide the what the sign to be stacked. For that, come to the factor. You can see the factor here, no? As you can see that x multiple is what? Here positive, here also positive. Plus into plus, plus. Or you can see here x square multiple is positive. When I'm multiplying the sign of both x, I mean to say I want the sign of the leading power, I think the highest power. So it is positive. So you write positive. As soon as you jump, change the sign. Negative. Again, change the sign. Positive. As soon you move towards the points. Okay. And this is the sign of f dash. Now you see carefully. This sign of f dash is positive. When sign of f dash is positive, the function is what? Increasing. And after reaching -1, sign of f dash is negative. Nothing but the function is decreasing. Okay. And after reaching 1, you can see the sign of f dash is again positive. So it is again increasing. So very clearly from the diagram, at x equal to -1, we have local maximum value. At x equal to +1, we have local minimum value. So x equal to -1 is point of local maxima. X equal to +1 is point of local minima. That's what we commented here. Okay. So we have two critical points. Now let's move on to the problem here. Question number 34, a 3-marker question. This will be our last question from this model paper and this chapter. Question says find the absolute maximum and absolute minimum value of a function given by this in the interval. So recall, we have discussed the concept about this. Whenever you have got closed interval, you can see here, and they are asking absolute maximum and absolute minima. First find the derivative of the function. Let us copy the function again. F of x is equal to 2x cube minus 15x square plus 36x plus 1. Now when I want to differentiate this 2 as it is, derivative of x cube is what? 3x square minus 15, x square will be 2x, then 36 as it is, derivative of x is what? 1, then 1 is a constant 0. Again I'm applying this formula. Now here, what is simplify? 3 2s are 6x square, then minus 15 into 2 will be 30x, then plus 36. What is common here? 6. So remaining will be x square minus 6 into 5 is 30. 6 6 are 30. 6. Find the factors of this. So 6 is there here. 2 and 3. So minus 2 will give minus 5. So minus 2x square minus 3x plus 6. So here plus 6 times of common is here x. So you get x minus 2. Am I right? Then here what's common? Minus 3. So minus 2 minus plus. So 3 out, so I'll get x here. Minus into plus will be minus. 3 2s are 6. So common is what? X minus 2. So when I'm going to have x minus 2, remaining is what? X minus 3. Now we have got the factors of the derivative. Now we are going to do what? Equate to 0. When I'm going to equate to 0, to find what? Roots. See carefully. F dash of x is 6 times of x minus 2 into x minus 3 is equal to 0. Now let us try to proceed. Equate to 0, I'll get x minus 2 is equal to 0, x minus 3 is equal to 0. So we are going to have x is equal to 2 as well as x equal to 3. X equal to 2 belongs to the interval 1 comma 5 close interval. Even x equal to 3 also belongs to the closed interval 1 comma 5. So to find local maxima, local minima, now I have to find the function value at 1, 5, 2 as well as 3. First kindly make a note. Okay, dear students, let us continue recording now. Continue the problem. So let us copy this function again here. So f of x is equal to 2 times of x cube minus 15 x square plus 36x plus 1. Okay, so now this I'll take as equation number 1. I have to put all this value 2, 1, 5 and 3 one by one. So put x is equal to 1 in equation number 1. We are going to have f of 1 is equal to 2 times of 1 cube minus 15 times of 1 square plus 36 times of 1 plus 1. So 1 cube is 1, 1 into 2 will be 2, then 1 square is 1, 1 into minus 15 is minus 15, 36 into 1 is 36 plus 1. So that, let us try to simplify. So this will give us 21, 23, 24. Check it out. Is it 24? This difference will be 21. Correct? No? 1. Yeah. Then 21, 23, 24. Yes, 24. Next, this is our 1 value. Next, again put x is equal to if I put x is equal to 2 in equation number 1, our equation number 1 is here, so f of 2 times of 2 into 2 cube, then here minus 15 times of 2 square plus 36 into 2 plus 1. 2 cube is 8, 8 into 2 will be 16, minus 2 square is 4, 4 into 5 will be 60, sorry, 4 into 15, 4 5 are 20, 4 5 6 are 60, then this will be 2 6 are 12, 2 3 are 6 7 plus 1. So minus 60 plus 72 will be 12, so 12 plus 16 plus 1 will be 17, so I'll get to 29. Okay, so this value is 29. Now again put x is equal to, the next value is 3, so if I put x is equal to 3 in equation number 1, so we have got this. So if I put it here, f of 3 is equal to 2 times of 3 cube minus 5 times of 3 square plus 36 times of 3 plus 1. 3 cube is 27. 27 into 2, 2 sevens are 14, 2 2s are 4, 5, 54. Then 3 square is 9, 9 into 5 is 45, 9 was 9, 10, 11, 12, 13. Then 3, 36 into 3, 3 6 are 18, 3 3 9, 10 plus 1. So if you simplify this, what we can get, if you subtract, okay, first if you add this 108 plus 1 will be 109, right now, then plus 54 will give us 3 here, border 163, subtracted 135. So here 5 and here border 113, so 8 here, then 2, okay, 28. F of 3 also we have got. Now what next? F of 5. Let's compute. Okay, let's compute the next value, x equal to 5. So putting put x equal to 5 in equation number 1, we are going to have f of 5 is equal to 2 times of 5 cube minus 15 times of 5 square plus 36 times of 5 plus 1. Now here we should be careful, that's a simplification. 5 cube, as we know, it is 125. Then 15 into 5 square is 25. Simplify this, 5 5 are 5 square is 25. So 5 5 is 25. 5 1 is 5 6 7. Again 2 5 is 10. 2 1 is 2 3. So this will be correct now. Yeah, 25. So 375 we are going to have for this. So 375, and here also no, 2 into 125 will be how much? 125 into 2. 2 5s are 10. 2 2s are 4 5. 2 1s are 2. 2 5s are 10. 2 2s are 4. 250. 250 minus here 375, and here 5 6 are 30, 5 6 are 30, borrow 3 5 are 15, 16 17 18 plus 1. So now let us simplify. Let us do it here. So 250 plus 181 here. So 250 plus 181. So 1 here, 8 9 10 11 12 13. So borrow 1 here. So I'll get 431 minus 375. So if I subtract with 375, so 3 borrow 1 here. Anyway, calculator is allowed in exam, so I'm just doing without calculator. And here 3 gone, and 2 8 9 10 56. Yeah, f of 5 is 56. Therefore the absolute maximum value, come on, compare among 24, 29, 28 and 56. So who is the largest value? 56. So absolute maximum value is 56. At which point x is equal to 5. X is equal to 5. Absolute minimum value among 24, 29 and 28, least value is 24 at x is equal to 1. So absolute minimum value is 24 at x is equal to 1. Kindly make a note. Fine. Yes. Yeah, with this we come to an end. of this chapter, application of derivative, all the problems we have solved along with the concept from model question paper. So all the very best, study well, give you 100%. Exam is nearing, so give you 100% dedication and commitment. Surely the remaining 4 chapters will be uploaded within this week. Thank you all. Thank you for your overwhelming support. Do like, share and subscribe to our YouTube channel Math Universe with Dr. Naseer Ahmed. Thank you all.